Hi everyone, we are going to start Chapter 4, Section 4, which is finding the slope of a line and using slope or interpreting slope as a rate of change. The objectives are to find the slope of a line looking at a graph, find the slope of a line from between 2 points from either a data table or just given the point coordinates, and determine the rate of change from slope and determine direct or indirect variation from the slope. Number 4, we're probably not going to get to in these sets of notes. All right, let's first talk about vocabulary and slope. Here we have the word slope, and I think some of you already have a good idea of what that's talking about. But it's basically how steep or flat a line is on a graph. So let's take a look over here at this picture. This is a skier. I don't know if it's obvious, but he's going down an extremely steep hill. It's very steep, and therefore the slope is going to be a high number. So the slope is describing how steep that mountain is. So very steep, the slope is high. Down here in the picture, it's kind of got a nice little easy hill here. It's kind of flat, and the slope is not very big, so the slope is going to be a low number. And in both cases, slope is a constant number, just a pure constant. So it's not variable, although we do use a variable as a placeholder to solve for the slope. But ultimately the slope is just a pure number, constant number that's not changing, and it describes how steep or how flat a line is. And just a little bit of a review, a ratio. There's a reason why I want to review this, but a ratio is a comparison of two things, and it's often written as a fraction. It's not always written as a fraction, but often. So, example, A compared to B. And always we read this, A is to B. Remember, though, it can be written with a colon. Okay, why am I reviewing that? Well, because the real textbook definition of slope is a ratio of the vertical change, that means up and down, called the rise. Many of you might have heard this before in middle school, to the horizontal change, called the run, between any 2 points on a non-vertical line. And this constant is represented by the letter M. Okay, so we always use M for slope, and that is a placeholder for the word mountain. So hundreds of years ago, when mathematicians were talking about slope, they thought of slope in terms of a mountain, and that's why I have here really two little mountains, a little hill and a steep mountain, to try and bring that point home. Okay, so slope, as I said, is represented by the letter M, and it is a ratio of the rise to the run. We read that as rise over run. Remember, the rise is the vertical. Whoops, got a poor spelling there. And the run is the horizontal. So hopefully you're already thinking that the vertical on the XY coordinate plane here, the vertical is the change in the Y coordinates. Vertical, meaning up and down, is really the change in Y, and horizontal is the change in X. So let's write that down. Change of Y, and the horizontal is the change in X. Okay. Let's take this a little bit further. So, slope of a line on the coordinate plane. Well, the slope, as I said, is represented by M here, and it's the rise over the run. The rise stands for the change of the y coordinates, y. And I'm also just going to say vertical, just to remind myself. And the run stands for the change in the x coordinates. Left and right can be described as horizontal. Okay, so over here we have a line, and it's a very nice straight line. So if you take any 2 points on that line, any, I have 4 listed here, but those aren't the only points. There's an infinite set of points on this line. If I look between C and D, for example, the rise, I'm going to count the spaces, 1, 2, 3. So the rise between C and D is just the vertical change between them is 3. And the run between C and D is the horizontal, or the change in x direction, and that is 1. So here, in this case, I have a slope of the rise is 3 over the run is 1. I can simplify that to 3. Down here, and here's 2 other points, A and B. And if you look at the rise here between A and B, you can see that it is also 3, and the run is 1. So you can see that the slope down here between A and B is also 3 over 1, or 3. And likewise, we can look at between B and C. Here, the rise between B and C is 3, and the run is 1. So again, the slope is 3. The point here I'm making is that the slope of a line is constant. In this particular example, it's a constant 3, and it'll never change. And if it does change, you don't have a line. The very definition of a line is a constant slope. It's not bending, it's not curving in any way, it's a constant straight line or constant slope, in this case 3. All right, so let's talk about the sign of slope. So the sign also tells us some information about a line. When I say sign, I mean positive or negative here. So a positive slope means that it is going up. You're walking up a hill. So here I've got a little guy walking up the hill. Now, when I say walk up the hill, we got to decide which direction. And slope, I want you to think of as left to right. We read words left to right. So think of slope going left to right. Are we going uphill? In this case, this little guy is going uphill. It's a positive slope. He's walking up. And a negative slope means that if you're walking down a hill left to right, then that line would be written with a negative slope. So let's just say that the slope of these 2 lines are roughly the same. So let's give this a slope. I'm just randomly coming up with a number. Let's say that this slope is 1 over 1. For every 1 unit to the right that this little guy walks, he's going up 1 unit. And so this would simplify to a positive 1. Well, let's say that this slope is, this gentleman here is walking down 1 unit for every unit that he walks to the right, in which case that would be a negative. So he's walking down 1 for every 1 he walks to the right, and that can simplify to a negative 1. All right, good. So let's further summarize that information here. So a positive slope is going uphill, left to right. A negative slope is going downhill, left to right. Now we do need to talk about 2 other types of slope, which would be zero slope. If you look at this line here, remember, slope is rise over run. In this case, there is no rise. It's 0. And the run is actually infinite. So we have 0 divided by infinity. And in this case, the slope is going to simplify to 0, because 0 divided by any number, including infinity, is going to be 0. And this last one is kind of tricky. This is a vertical line straight up and down. If we look at this, rise over run, Slope is rise over run. We have an infinite rise. It's just going straight up and down indefinitely. And the run, there is no run. It's 0. Well, we can't ever divide a number by 0. So we call this an undefined slope. A vertical line has an undefined slope. All right. Very good. All right, so let's determine a slope from a line graph. Over here we have a nice straight line. And how do we determine the slope looking at the graph? Well, we pick any points that we want. In this case, it's crossing here. The y-intercept, remember, y-intercept is where we cross the y-axis. And we have another point here. And I'm going to write the coordinates of these points. The coordinates here of this point is at x equals 2 and y equals 7. And of course, the y-intercept is going to always have x equal to 0, and then it's crossing the y-axis here at 3. All right, so we can just count the boxes. The rise here is 4 between these 2 points, and the run between the 2 points is 2. So we can just write rise over run, 4 over 2, and we can simplify that to 2 over 1, or just even 2. And in fact, you can even see that if you see this line is crossing the grid right there, and you could even simplify that and look at the rise between these 2 points. And the rise is 2 and the run is 1. So you can see that the slope is, in fact, 2. I want you to notice that you can also see between the coordinates here, we've got the change in the y. Okay, the difference between the y coordinates is 7 minus 3. So you can see that the rise is just the vertical change, 7 minus 3. And the run is the horizontal change. So if you just look at the x coordinates, would be the horizontal change, 2 minus 0. So that's another way you can see that the slope here is 4 over 2 or 2 over 1. Okay. And what does that mean? I should look at this here. This ultimately means for every 1 unit that line is going to the right, the line is going up 2 units. Okay, so that's important to summarize that. All right. And now let's look at these 4 examples and see if we can determine the slope of each of these lines from the graph. Okay, one of the first things I try to recommend is try to figure out the sign first. It just makes things a little bit easier. And if we're reading left to right, this guy would be walking uphill, so the slope is going to be positive. All right, so try to look along the line, maybe left to right, and see where does the line cross the grid at an integer. And I see the first point would be right here. And keep going up that line, and you can see another point that crosses right on the grid would be right here. And you can see, if you're doing things right, you can see a pattern actually. So let's take a look at the rise between these 2 points here. The rise is up and down, so we see that the rise is equal to 1 unit. Just straight up between those 2 points here, we only have 1 unit. And the run is 2 units. That would be in the horizontal direction, and that would be 2 units. So here we got a positive slope of 1/2. What does that mean? That means for every 2 units we're moving to the right, the line is going up 1. Over to the right 2, up 1. Over to the right 2, up 1. And you can see the repeated pattern. All right, next example over here to the right. Try to determine, are we walking downhill or uphill? Well, if we got our little guy here, you can see that he would be walking down if going left to right. So we know right away that our slope is going to be negative. So try to determine that first, just so you don't make a little mistake. Now look along the line, and whoops, that's not what I want to do. Look along the line here and see where does it cross the grid perfectly. So I'm going to start up at the top. It looks like right there is a point, and I'm traveling down, the y-intercept right there and here, and you should be seeing a pattern develop. We've got a rise here. The slope is rise over the run. And our rise, of course, isn't a rise at all. It's going down. It's going downhill. And let's count the boxes. 1, 2, 3, 4 in between those 2 points. So we would represent that as a -4 because we're going down. And the run between those 2 points is only 1 unit. So we've got a slope of -4 divided by 1, or -4. And you can see the pattern. What does this mean? This means that for every 1 unit going to the right, the line is going down 4. And you can see it repeating, moving over 1, down 4. Move over 1, down 4. Over 1, down 4. Let's quickly take a look at some coordinates. This point here is -1, +8. Sorry that the scale is so small. This point here is 0, 4. It's the y-intercept. If you take a look at the rise then, that would be the change in the y, because rise is vertical. So you're looking at the y coordinates here. So the change or difference between 8 and 4 over the difference between -1 minus 0. That's 4 over -1, which is -4. So I want you to see both from a numerical perspective, from numbers, as well as visually, where this rise and run is coming from. All right, next, again, we have an uphill going left to right. Our little guy would be walking up, so we have a positive slope. And going along the line, I'm looking for areas, points that I can find that are crossing perfectly on the grid. So if I go left to right, the very first point I can see is right here. And I'm going to continue to travel along that line, and I see right there we're crossing the grid. And I'm continuing to travel, and hopefully I can see a pattern develop. So the slope is represented by the letter M for mountain equals rise over the run. And here, our rise between this point and this point, our rise is only 1 unit. And our run between these 2 points is 1, 2, 3, 4, 5. So our slope is a positive 1/5 for this line. What does that mean? That means for every 5 units we're traveling to the right, we're going up 1 unit. And finally, this last example here, again, try to determine the sign of the slope. Here we'd be going downhill, so we know this is a negative slope. And try to find any kind of area where the line is crossing the grid perfectly. I think it crosses there at the top, but I'm not totally sure, so I'm going to start here and there. And try to see the pattern, because if you're not seeing a pattern, sorry, the alignment is a little bit off on my stylus here. All right, so we've got 4 points here looking for the pattern. The rise is actually going down 1, 2, 3 units. So I've got slope equals rise over the run. And my rise is actually going down 3, so it's -3. And my run is 1, 2. So it's got a run of 2 in between every 2 points. So my slope is negative 3/2. What does that mean? That means for every 2 units to the right, we're going down 3 units vertically. And one more example of just showing that with the math. This point is located at negative 5, positive 6. This point is located negative 3, positive 3. So again, rise over the run. Rise is the difference in the vertical direction. So vertical would be our y coordinates. So the rise over the run, the rise is going to be this 6 minus 3, 6 minus 3, and the run here is going to be the change in x dimension. So we've got negative 5 minus, and this is where the numbers get a little tricky. We're subtracting negative 5 and negative 3, so I got to be really careful there. I'm subtracting here a negative number. So we've got 6 minus 3 is 3, and negative 5 minus a negative 3 is negative 5 plus 3. So we have 3 over negative 2, and just by convention, we like to put that sign up with the top number. So negative 3/2, and you can see we get the same number visually as we do by calculating. All right, let's see if we can find the slope from a table. Here we have a function, y equals 3x minus 2, and I have a set of domain here. Remember, those are the input values. Domain, I'm going to write that down. Domain is the input, is the independent variable of the function, and I'm going to substitute x in and solve for y. So we've got y equals 3. I'm going to get rid of that x and put in negative 1 minus 2. That's negative 3, right? 3 times a negative 1 is negative 3. Minus 2 is negative 5. Y equals 3 times 0. Of course, that just goes to 0. Minus 2 is negative 2. Y equals 3 times positive 1 minus 2. Whoops. Not minus 3, it's minus 2. That is 3, positive 3 minus 2 is 1. Y equals 3, I'm going to substitute in 2. That's 6 minus 2 is 4. And finally, y equals 3 times 3 minus 2, that's 9 minus 2 is 7. Now what we're looking for is patterns. Remember, the change here in the x, in the horizontal x-axis is the run, and the change in the y, the vertical, is the rise. So what is the pattern here? I've got negative 3 going up to 0. Well, that is adding 1. 0 up to 1 is adding 1. 1 up to 2 is adding 1. You see the consistency here. So when you see that consistency, you know you've done something right, and the change in the x dimension here is the run. That would be the horizontal. So over here I'm going to say the slope equals rise over the run. So far we know the run is consistently going up by 1. Now let's look at the rise, or the change in the y numbers here. If you look, we have negative 5 going up to negative 2. Well, I need to add 3. Negative 2 up to positive 1 is adding 3. 1 up to positive 4 is adding 3. And 4 to 7 is adding 3. You want to see this consistent. If you don't have these numbers all constant, you know this is not a line. It must be constant. So our rise then is going to be positive 3. So just from this table, we can see 3 divided by 1 equals 3. Our slope of this function is 3. And I'm just going to give you a little bit of a hint. Look at this number here right in front of the x. We're going to be talking about the standard slope and y-intercept form soon, and we'll find some interesting things happen. Okay? Right, now let's just purely look at the math or numerically how to calculate the slope of a line that would connect between 2 points on the coordinate plane. Here we don't have graph paper, but we know that slope is rise over the run, and here the rise, this rise is the change in those y coordinates here. It's the up and down, the vertical. Actually, I'm going to write that. The rise is the vertical, and the run is the horizontal. So you can see that all we need to do is get the difference between the y coordinates and the ordered pairs of the 2 points, and get the difference between the x coordinates. So here we know that we always have x first, and I'm going to use, they're called sub-numbers here. We've got an x value here and a y value, another x value and another y value. I'm going to differentiate between the 2 points by saying this is x1, y1. It's really labeled x sub 1, y sub 1. And I'm going to call this x sub 2 and y sub 2. And you don't have to do that. You could have put these as x2, y2, and x1, y1. It's fine, but you just have to be consistent. Now the rise is the difference between the y coordinates. So here I have the rise is the difference between y1 minus y2. So I'm going to put in 5 for my y1, that's how I labeled it, minus 3 for y2. And the run is the difference between the x coordinates. This is the horizontal change. And so I started out here with y1 first, so I'm going to have to start with x1 first. I have to be consistent. X sub 1 is 2, and I need to subtract, well, got to be real careful here because I'm subtracting a negative number. So I'm subtracting -4. 5 minus 3 is 2, and 2 minus a -4 is really 2 plus 4. So here I have 2 over 6. And I can leave my slope that way. That just says for every 6 units to the right, my line is going up 2 units. Or if I wanted to simplify that, I could. Both of these numbers are divisible by 2. So I can rewrite 2/6 as 1/3 if I want to. Okay, let's see if we can do these next 2 examples here without graph paper. So I am going to just assign which point I want to be x1, y1, and x2, y2. And I could have done it in the opposite direction. It doesn't matter as long as you know which one is 1 and 2 and you're consistent. So the slope is the rise over the run, and the rise is the difference of the vertical coordinates, which is the y. So I'm going to say y1 minus y2. It doesn't have to be that way. I could have done y2 minus y1. But if I do put y1 here first, then I have to put x1 here in the run, minus x2. I have to be consistent. So y1, if you look here in our assignment, we made y1 6, and y2 is 2 over here. And x1 we assigned 4 minus, and in this case, x2 is a negative, so I have to be very careful. I'm subtracting a negative number. 6 minus 2 is 4, and 4 minus -1 is really 4 plus 1. So I end up with a slope of 4/5. What does that mean? That means it's a positive number, so our slope is going up and to the right, uphill. And that just means for every, let's say, 5 units to the right, and this is certainly not drawn to scale, I'm going up 4 units. That's what that slope means. Okay, example 2, find the slope of the line between point C, which is at -7, 2, and point D, which is -3, 4. We know that the slope equals rise over the run. And I'm just going to show you an example here. I'm going to go ahead and call this x1, x1, y1, and x2, y2. And I'm going to show you an example where I'm going to use the x sub 2 and y sub 2 first, just to show you that as long as you're consistent, you're okay. So I'm going to say the rise is the difference between the vertical coordinates, which is, I'm going to say y2 minus y1, and x2 minus x1. So in this case, I've assigned y2 to be 4, and y1 to be 2. And x2 is -3, and x1 is -7. So I'm subtracting a -7. Again, I have to be careful. All right, hopefully my daughter has stopped singing the Friends theme song here in the background. 4 minus 2 is 2, and -3 minus a -7 is really -3 plus 7. And then I have 2 over -3 plus 7 is a positive 4. And I can simplify that if I want to 1/2. But you don't have to. So again, this slope happens to be positive, and what it's saying is for every 4 units to the right, we're going up 2 units. And we can look at that as for every 2 units to the right, we're going up 1. All right, last page. We're going to interpret slope as a rate of change here, so let's take a look at the first example. Gas prices. The table shows the cost of a gallon of gas for a number of days. Find the rate of change with respect to time. Well, first of all, I want you to remember that time is almost always, I would say nearly 100%, the independent variable. Okay, so that is going to be like an x. It's going to be the input. So I want you to remember that almost always in science, experimentation, etc., time is the independent variable. So I'm going to put the input. And something else is going to be the output. So here time is the input, and the price of gas is the output. Okay, let's look what is happening in the trend here on the time or the input. From day 1 to day 3, what's the change? We're adding 2 days. Day 3 to day 5, change 2 days. So far so good. That's consistent, and that's what we need for a linear function. Now let's take a look at what's happening here in the price. We've got $1.99 per gallon going up to $2.09. Well, what is the difference there? I'm going to go ahead and look at the difference of that by taking the difference. And 9 minus 9 is 0. And I have to borrow here. I'm going to do that in blue. I'm going to borrow, and I've got 10 minus 9 is 1. And then 1 minus 1 is 0. So I have 10 cents difference here. I'm going to represent that way. And again, I have to look at the difference between $2.19 and $2.09. And 9 minus 9 is 0, 1 minus 0 is 1, and 2 minus 0 is 2. So good news, it's also constant, and that's what we need for a function, or a linear function. M equals rise over the run. The rise, in this case, is the output. Okay, so we've got 10 cents is our rise, positive, and the run is 2. And this is fine. We can leave the slope, or is the unit change here, or the rate of change, I should say, is 10 cents divided by 2 days. Maybe I'm even going to put that here. So what does that mean? It means for every 2 days of change, the price of a gallon of gas is increasing by 10 cents. Well, this is called a rate. And if you remember, we can always change every rate into a unit rate by making the denominator equal to 1. So if I want to, I can make this denominator 1 by dividing by 2. Well, if I do that, I have to divide the top by 2. 10 cents divided by 2 equals 5 cents. That's 5 hundredths is 5 cents. And then 2 days divided by 2, of course, is 1 day. So what does this mean in our unit rate? Our unit rate says that for every day, the price of a gallon of gas is increasing by 5 cents. All right. And finally, the last example. The table shows the change in temperature over time. Find the rate of change in degrees Fahrenheit with respect to time. Again, time is nearly always considered the input. So that's kind of like your x, your independent, your domain. And here we're going to consider the other variable, the output. All right, let's look at the change here. We've got 0 hours going up to 2 hours. That's a change of 2 hours. 2 to 4, 2 hours. 4 to 6, 2 hours. So here, our input, our x, is the run. And over here on our output, the rise. What's happening here? We've got 38 going up to 43. Well, that's a difference or a rise of 5 degrees. 43 going up to 48, again, is 5 degrees. And 48 going to 53 is 5 degrees. So our slope is rise over the run. And if we look at this, we've got a rise of 5 degrees Fahrenheit. And we've got a run of 2 hours. So this is a rate, and what does this say? This is saying every 2 hours the temperature is increasing because it's positive. It's increasing 5 degrees. That's our rate of change. Now we can also simplify that into a unit rate. And how do we do that? Well, we're going to change that denominator here to 2. So, to 1. So we've got 5 degrees Fahrenheit. I'm just going to rewrite this over here, 2 hours. I want to divide that by 2 in order to get 1 hour here on the bottom. If I divide the bottom by 2, I've got to divide the top by 2. And 5 degrees divided by 2 is 2.5 degrees Fahrenheit. So what does this say? This means for every hour, the temperature is increasing 2.5 degrees Fahrenheit. Thank you for listening. Take care.